Okay, so let's look at example 5. A prototype automotive tire has a design life of 38,500 miles with a standard deviation of 2,500 miles. 5 such tires are manufactured and tested on the assumption that the actual population mean is 38,500 miles and the actual population standard deviation is 2,500 miles. Find the probability that the sample mean will be less than 36,000 miles. Assume that the distribution of lifetimes of such tires is normal. Now, that last sentence is very important for us because we're only looking at a sample size of 5, which means as far as sample size, the central limit theorem will not apply to our sample size. But we are given that the distribution is normal, which means that we can use our z-score and we can use the norm.s.dist in our Excel. If we did not have that little statement saying that we're going to consider the distribution normal, we could not use that same method of calculation. So that's very important. All right, so let's go ahead first of all and get the mean of the sample mean and the standard deviation of the sample mean. So, all right, so, oops, let me get that stuff off the page here. So we're not looking at it. All right, so the mean of x bar. All right, recall that's the same as our population mean. So if we look back at our example, that is 38,500. All right. And then the standard deviation of x bar is equal to our population standard deviation divided by the square root of our sample size, which in this case is 5. All right, so let's put 2,500 divided by the square root of 5 into our calculator. That gives us 1,118.033989. All right, now let's go ahead and do our calculation using our z-score. All right, so let's notice we want to know what's the probability the sample mean will be less than 36,000 miles. All right, so using our formula, z is going to be x bar, our 36,000 miles, minus the mean of x bar, 38,500, and I really needed to put that in parentheses, divided by, divided by the population standard deviation divided by the square root of 5, which is what we found right up here. So 1118.033989. All right, so let's do that calculation now. 36,000 minus 38,500 is going to give us negative 2,500. And now let's put the rest of that into our, and we end up getting negative 2.236. All right, now we're going to stick that into Excel and get our actual probability, but let's notice what we want. We want the probability that it will be less than 36,000 miles. The sample mean will be less than 36,000 miles. And since it's less than, we can report exactly the probability we get out of Excel. All right, so let's put negative 2.236 in there. So equal norm.s.dist, negative 2.236, and true. And that probability is 0.0127. All right, so let's report that. So essentially, there is less than, if we move our decimal place, or a little bit more than 1% chance that these prototype tires will last for less than 36,000 miles.